Hello everyone, I hope everyone is great. So today we'll do a lab by cyber defenders called the T1197 lab. Alright, so let's read the scenario and answer the questions. Okay, the scenario says adversaries have the capability to exploit bits job, which is basically like a background intelligent transfer service, which is in Windows. Jobs for the purpose of persistently, and it's also used for file transfer. Okay, for the purpose of persistently executing code and conducting virus background tasks. Okay, window background intelligent transfer service is a COM exposed low bandwidth file transfer mechanism. Okay, used by the applications like update and messengers which operate in the background without affecting other network applications. In this incident, an employee received a multiple alert from Windows Defender regarding the presence of malicious file, okay, on their PC. As you arrive on the scene of the incident, your objective is to use the Splunk and analyze the event logs of the suspicious machine and determine the nature of the event. All right. So this is a kind of the overview of the scenario. Okay, so now let's see the questions. Okay. Question number this is the Splunk user interface. This is the question. Say, what's the framework used to create the backdoor? All right. So since there's a backdoor, there's of course a malware, and we know from the scenario that the Microsoft Windows Defender has identified, has alerted us. So we know that there's a malware detected. So what we can do is to do event code. We have the index here 1116. And for those who don't know what this event code stands for, it stands for like malware being detected by Microsoft Defender. Okay, as you can see here. So let's see. Let's see what we have. Okay, let's look at this event for example. Okay, we are seeing Microsoft Defender. Okay, it has severity of severe, category of Trojan, and we can see this one, the name of the malware, Trojan Win32 Metapredator. So if you are familiar with penetration testing, we know that Metapredator is associated with the Metasploit framework, which is which is an infamous exploitation framework. So we can assume that since it's a Metapredator, uh, malware, we can assume that the framework is Metasploit. All right. So let's say Metasploit. All right. So it's correct. And if you want to see here, Metasploit. This is the exploitation framework. It's really, really popular. So it's by penetration testing, etc. All right. On to the next question. The next question says, what's the name of the scheduled task that the attacker tried to create? All right. So what attacker usually do is that in order to persist in the machine, they create a scheduled task so that like when the machine is turned off, the scheduled task at a specific time, it will, run a specific task so that it will run the malware that has been created by the attacker that has been, you know, in the back door of the machine, right? So what we can do actually here is just we can do a small change, all right? Instead of event code 1116, we can do actually event code 4698. All right. And event code, for those who don't know, event code 4698 stands for the creation of scheduled task. Okay. Scheduled task was created, event code 4698. Okay. Now let's see, what kind of task has been created by the user. So, okay, task content, task name. Okay. And this is like, let's add it actually. Let's add it here. Okay. Okay. Let's create a table. Table. with the task name that has been created. Okay, and as you can see, these are the tasks that has been created. We have OneDrive reporting, Microsoft Windows, Defender cleanup, and we have here something called evil task, which is actually suspicious. All right, so this is possibly uh the malware that has been created by the schedule task that has been created by the attacker. And yes, it's correct. It's evil task. Question number three says, what is the lol bus used by the malicious actor to move the backdoors to the targeted machine? So you can copy this lol bus to know its meaning, just to show you lol bus meaning. So lol bus stands for living off land binaries and scripts, which are they are legitimate tools that hackers can abuse to run malicious payload on Windows system without triggering defense mechanisms. So we can think about them are like legitimate process that are abused by malicious actor. So what we can do actually, since it's a process and it's so it has to be have a code. So let's say even code 4688, which stands for process creation. What we can do is actually stats count by. Okay, let's see if here, as you can see, we have a parent process. Since it's a process, we'll copy this one. Count by parent process, and we have here new process name, which is part of the parent process, and then we can sort by count. Okay, so as you can see here, we have here the parent process, and here we have the new process. You can see here we have PowerShell. And for those who don't know, PowerShell is often abused by attackers, so it's a very indicative of malicious actor. And we have the process called bits admin. Okay, where we have services, looks normal. But if you look at this bits admin is a command line tool that can use to create, download, or upload jobs and monitor their progress. So it's a legitimate process, but we believe that this might be the process that's abused by the attacker. So if we look at the answer here, it's indeed bits admin.exe. Nice. Okay. To question number four. Question number four says, what was the first attempt made by the attacker to execute the lol bus? Okay. So far we know that it's bits admin, right? We know it's bits admin, so we can add this to our search. Okay, to see when it was executed. Okay, we can add it here. Okay, we'll delete this. Okay, so we can remove this one. We can create a table, all right, where we sort the time and the new process. First, let me copy the field, the time. Okay, event event code call to 4688. Okay, let's cover this one. Let's copy this one. All right, so we know we have this one. So here, let's make a table for time and for the creation of the new process, not the parent process, the new process name. Okay, and run. Okay, so we can make this one, Control C, equal to, or we can first remove this path. Okay, and let's add asterisk. All right. And okay, since we have this one, let's sort the time. Okay, we can sort the time. Um, sort time. So you can get the earliest one here. So because as you can see, this one was in 2003, 731, 551 and 28 seconds. And this one was in 551, 25 seconds. So this one was the latest. The question asked for the first attempt. So the first attempt have to be down here. Okay, we have 539. Okay, so we have to sort the time, yeah, here, sorry. Like this. Okay, so here is the earlier one. 5:39:45. Okay. Bits admin at this time. Okay. So let's try to copy it. And they want also the hour. So sorry. This 3. Control C. And okay, it says it's not correct. Oh, full stop. Okay. Congratulations. Okay. Back to question number 5. What's the IP address of the attacker? All right, here. Uh, if you don't have an IP field, of course, let's remove this one. Okay. So let's run this. So in order to find the IP address of the attacker, since the attacker has abused task with this process, which is a legitimate process, even ID for the job process is actually job creation and job modification is actually 59, and let's say or event code 60. All right, 60. So here 59, and this stands for the process of the bits job creation or job modification. All right, and here we can search, right, and we can see here. Okay, we can see here, for example, this we have already like 55 events, and in this, for example, we can see here bits stop transferring in this message job associated with the HTTP 192.168.test.xurl. Okay, so we can think of that since it returns this message that this is the attacker's IP, right? But in order to let's say to be more have a better view, let's create a table. Okay, table where we have a time, and let's say let's search for the here URL, any field associated with the URL, data URL. Okay, let's add it, selected. Okay, and here we have it. Let's copy it, copy, and let's add it here. Okay, as you can see, yeah, this is the attacker IP in the data URL 192.168.90.136, and try to run this test.exe and then r for n.50.exe. All right, so we can assume 192.168.90.136 is the attacker's IP. At indeed, it is. Okay, the last question say what was the most recent file downloaded by the attacker to the targeted machine? Okay, so we have these are the files. Okay, test .exe. Okay, but here they are asking for the most recent, so they are asking for the latest. And as you can see, since this is in from latest to earliest, we have here it's like 6, 8, 6, 16, and 48 seconds. and here we have like 6, 1648, 6, 12, 31. So we can assume this one is the latest one. So it's in 2023, 731, 6, 16, 48 second. Okay. So this is the latest file that that the attacker want to upload to the targeted machine, and it is test.exe. So as you can see, this is the correct time in the 24 UTC format. So this was the end of this lab. I hope you enjoyed the tutorial, and see you in the next one.